Welcome back. In the previous chapter, you would have got an idea about how pass by references work in Java, especially when you pass a reference type to a method. A similar concept is applicable for returning types from a Java method as well. In this chapter, we will explore the way Java handles return types. So there are three types of data that you can pass primarily. You can return void, which is nothing but returning nothing, where you have to indicate that information in the program. Then you can pass a primitive type or you can return reference type. So how are these handled is something what we will explore in this particular chapter. A method can return any type of data, or it could be a primitive type, or it can be a reference type as well. In addition to this, it can be a void also. So void is nothing but a keyword which is representing that method does not return anything. That's it. So you could basically say a method does not return anything by indicating void as a return type keyword. In addition to this, a method can return a primitive type where in this particular case, just like passing the arguments by value, so you have a copy of the primitive type value returned to the calling method. So this is very much important to understand as well, pretty much in line with pass by value concept we have discussed. In case a method is returning a reference type to a particular object, in that case again the concept of pass by reference is applicable where a copy of the reference to the object is returned pointing to the actual object only. So this is the basic ways in which a method can return different types as well. So let us take a look at the concept of how a primitive can be returned by a particular method. So let's take a simple example here. For this particular example, I have taken a class called incrementer. So incrementer, as the name itself says, it is just a simple class where it has a value. So initially the value will be 0. So whenever an object is constructed, and then it has a method called increment, and when you invoke the method increment, it will make or increment that particular value by 1. So by saying current value plus plus. It's a very simple program, and at any point in time you can also get the current value where it returns the current value. So here you could see that there are two methods we have, so which is void, which we have been using, and int, which we are also using. So but now let us look at the behavior of this particular functionality. So let us look at incrementer demo. So let us run this particular program here. So what we have done is very simple. So we have created an incrementer object, and then we are incrementing this by once, so it automatically increments the data, and we are printing the current value. So the current value is nothing but 1, and we are taking that particular current value as a return value, and we are basically holding that value. And then I am modifying the value outside the method. So the method has returned a primitive type, the current value in this example, and I am modifying the data and again printing that modified values. As you see here, the modified value is 10, and we are also invoking the getCurrentValue method. So incrementer.getCurrentValue will still hold the actual value, which is 1, which means a copy of that data was passed, and any changes you do outside the method is not affecting the state of the particular object, which is nothing but data encapsulation, and we will discuss this concept in the future sections. Okay, now let us go ahead and come back to this particular concept of method changing. It is also possible that we can pass a reference type as a return value. So return could be a reference type, and when you do return a reference to an object, a copy of that reference variable is being passed and both point to the same object, as we have already discussed the concept of pass by reference. So in this case, a method is basically returning the current object reference itself. So this is another concept called as a method chaining. So what is method chaining? So let us go back to the incrementer class here, and then let us see that we have a method increment where instead of making it void, we are modified this to return an incrementer object itself. So what is that? So here it will implement the logic current value plus plus. In addition to this, what it will do, it will return this. What is this? We all know this is the current object reference itself. So it just passes the reference of the current object, and you have a reference to the current object as well. And with this, we could basically bring in another interesting concept called as method chaining. So you could see here incrementer dot increment dot increment dot increment. So you can do multiple times and you can invoke, because dot increment returns increment object, dot increment returns another increment object. So that's a basic concept. So here let us refactor, or let us modify the program here and try to understand the same behavior. So let us go here and then say, let us modify this to, let us say that it returns incrementer, return this. Okay, so this program is complete now. So now let us go ahead and implement this incrementer with method chaining. So let us say increment, we already have the incrementer dot increment dot increment dot increment. So which means I am invoking the increment method multiple times with the reference of the object that I am getting. So every time I am calling in increment, I get the same object. So this is a concept called as method chaining, and this is basically used in another important class called string builder. We'll discuss about string builder in the later chapters. Okay. So now let us bring the value dot current value. So if you look at this particular program, so let us run this program, maybe to understand how this works. The initial part will be remaining as it is. So here you see, so the current value is 1. So we are doing the increment 3 times. So it gives the output as 4. So it internally holds that particular state, but returns a reference type. So this is a basic concept of returning an object from a method. With this, we do have another interesting concept called recursion. So recursive calls, so again in other programming languages also we would have come across this particular concept. A classic example is factorial. So in this case, a method calls itself in order to solve a problem. So what do we mean by that? Within the method, so in the previous example we saw the current object reference is being passed or returned to the calling method. So that's one aspect. But here a method A calling itself, calling a method A well within that particular logic. So that's a basic concept of recursive method call. So it is an important condition that is required. So whenever you implement a recursive method, it is important to have some kind of an end condition or a stop condition where the recursion ends. Otherwise, it will be infinite, and that's not a good sign, right? So we need to ensure that we implement this logic. For this example, we have taken a very simple classic concept called factorial. So we know factorial of a number is, for example, if you say factorial of 5, so 5 cross 4 cross 3 cross 2 cross 1, or 5 into 4 into 3 into 2 into 1. So that's the basic concept where it comes and stops at 1, and that is the concept here. So where we have int factorial, so fact of integer n, it basically has a result as n, and if it is equal to 1, it returns 1, else it will return a factorial of the previous number into the current number. So if you say, if you pass 5, so it result will be factorial of 5 minus 1, which is 4 into the current which is 5. So that's why we want 5 into 4. Okay, and then return the result. So this is the place where it would basically be invoking multiple times till it reaches the end condition, which is 1. So if it is 1, then it will just return 1, and thereby you get the factorial of the particular number. So this is a classic example we've been using in other programming languages also, and in this example we have seen how to implement this in Java. So let us take a look at how this works. So let us run this particular factorial program and say factorial of 3. So internally it is invoking multiple times and gives the outputs. So this is a very simple example which is about recursion in Java. So these are the different types that can be returned from a Java program. So to summarize, a Java program can return void, indicating that it is not returning any value or any type. So that itself is a simple keyword to indicate that this method does not return anything. Okay. The second option is to return a primitive type, and the third option is to return a reference type. So a reference type can be of any type, which we have already discussed. It can be of a class type, interface type, custom type, anything, or even an array. So this is the concept which helps you understand what is returned from a particular method and how it is basically handled by the called program, and if there are any changes made, whether it will affect or not is something determined by what type of data is basically returned by the Java program. I hope you like this. In the next chapter, we have a hands-on exercise where I want you people to complete the hands-on, where you will understand the concepts we have discussed in this section with respect to pass by value, pass by reference, and returning different types of data. So happy coding.